Akuri. Well, that's the way we say hello in Madagascar. Hello, children. How are you people doing? I'm Saurabh Kumar Dutt, and I'm here to teach you people a little bit of mathematics and to make your mathematics strong. So children, before we get started, let's quickly look up about this interesting place. This is Singi de Be Maraha, Madagascar, Africa. It is here that you'll get to see labyrinths of tarring limestone needles, Singi peaks where you cannot walk barefoot, gorge of the river Manambolo, mangrove swamps, and also the special species of lemurs. I'm sure you will be really amazed to see the flora and fauna of this place. So be here, have good fun, but do not forget to have the local sweet dish of Madagascar, which is Kobo Ravina, and also to tell all the people of Madagascar that you get to meet Akuri. In this note, children, I'm going to start off this lecture where today we'll be discussing a little about polynomials. We will have an idea about what a polynomial is. Further, we'll be looking up how we can find out the zeros of a quadratic polynomial, and then we'll be looking up a sum, which I'm sure is going to open your eyes. So let's get started, children, and let's have all of this mathematical fun. Now first, children, whenever we talk about polynomials, just look up that polynomial is an algebraic expression which has constants, variables, and some separators. For that matter, let us consider that we have some ax square bx c, right? So this is an algebraic polynomial, or in other words, you can say that it is an algebraic expression, right, which has constants. Now if you talk about this a, or if you talk about this b, or if you talk about this c, all of these three are constants. Now if you talk about thus the initial alphabets of English language like A, B, C, D, they are normally considered as constants. And if you talk about the latter alphabets like X, Y, Z, etc., they are considered to be variables. Now here there is no separator in between. For that matter, whenever we talk about separators, we have either a plus sign or a minus sign. So what are these? These are separators, right? And further here, children, if we talk about A, B, C, they are constants like I told you. And then if you talk about X, Y, Z, etc., they are what? They are your variables. Now when we have a mix of all of these, then we say that we have an algebraic expression. Now here, children, let's have an idea how we can have a separator. For that matter, if say we have some ax square plus bx minus c. So here we have two separators, right? And as we have two separators, thus there'll be three terms. Thus comes the definition of a term. So whenever you have an algebraic expression like the one that we discussed first, which doesn't have any separator in between, it just has constants and variables, then it will be known as a term. If you have one separator, then there'll be two terms, as the whole algebraic expression will be separated into two parts. And if there are two separators, obviously there will be three parts, and those three parts are known as three terms. As such, this will then be known as a trinomial. So having one term, it's a monomial. Having two terms is a binomial. Having three terms is a trinomial. And whenever an algebraic expression has more than three terms, then it is known as a polynomial, right? So here, children, we are looking up the chapter of polynomials, where we are looking up a small fragment where we can find out the zeros of an algebraic expression when it is quadratic. Now here, children, whenever we talk about the general quadratic expression, remember, it is this that I wrote earlier here, that is ax square plus bx plus c, and that can be considered to be, say, some f of x, right? So if you have an algebraic expression which is not equal to 0, you will say that it is so, that is an algebraic expression. But if it is put equal to 0, then you will say that that is an algebraic equation. Now here, as the highest power of the variable is 2, thus this is quadratic. If the highest power of the variable would have been 1, then you would have said that it is linear, and if the power of the variable is 0, or in other words you have no variable, then it will be said to be a constant. For that matter, let's quickly look up what a constant expression will be. Let's say we have some a times of x raised to the power 0 plus b times of y raised to the power 0. Now I'm sure you people remember by exponents that if any number is raised to the power 0, that becomes equal to 1. As such, this next will be converted to just a plus b. As such, this is a constant expression and it does not have a variable like x, y, z. Okay, so if you have an algebraic expression which is quadratic, that means the part of the variable is 2, then we can find out the zeros by considering the zeros to be, say, some alpha and beta. Now the sum of these zeros, alpha plus beta, is given to be equal to minus times the coefficient of the linear term divided by the coefficient of the quadratic term. Now what is the coefficient? The coefficient is the number which is multiplied with a variable. So here b is a number or is a constant which is multiplied with x. As such, it is said to be the coefficient of the linear term. Similarly, a is multiplied with x square, and thus it is the coefficient of the quadratic term. Now children, alpha plus beta being equal to minus b upon a, we now have another expression that is alpha beta, or the product of the zeros, to be equal to c upon a, right? So these are the two formulae that you're going to use to solve the sum. Now before I get started with the sum, I'll just quickly revise all of this so that if there is any doubt, all of that gets cleared. Now here children, first we talked about what a polynomial is. So whenever you have an algebraic expression which has some constants, variables and separators, it will be said to be a polynomial in general, right? And in specific, if you want to talk about a polynomial, then that is one such algebraic expression which has more than 3 terms. Okay, now here children, if we talk about this a, b and c, they are constants. They are just like numbers 2, 3, 14, etc. Now if we talk about the latter alphabets like x, y, z, they are considered to be constant variables, right? So here this x in x square or this x, they are both variables, right? Now children, as you see that in this algebraic expression we do not have any separator, right? We now write an algebraic expression where there is a separator. That is, if we have ax square plus bx minus c, here plus and minus are the separators. So if there is an algebraic expression which does not have a separator, it will be known as a term or a monomial. If it has one separator like plus sign or minus sign in between, then it will be known as a binomial. If it has 2 separators like this, then it will be known as a trinomial. More than 2 separators, that is 3 separators or more than 3 separators, then it will have more than 3 terms like 4 terms, etc., and then it will be known as a polynomial. Now here in this chapter children, we are talking about the general word polynomial. That means it can either be having a single term, 2 terms, 3 term, 4 term, or probably as many terms. Now our general quadratic expression is ax square plus bx plus c is, say, some algebraic expression, and this algebraic expression is special because the highest power of the variable x is 2, right? And whenever you have such an algebraic expression where the power of the variable is 2, then it is known as quadratic. Now in this quadratic expression we have 2 zeros because as is the power of the variable, that many roots or that many zeros we'll be having. If suppose the power of x would have been 4, then there would have been 4 zeros or there would have been 4 roots. Here thus this algebraic expression will have 2 zeros, or in other words it will have 2 values of x such that this expression can be made to be 0. Now in order to find out those values, what do we do is we consider those zeros to be, say, some alpha and beta. For that matter, you can consider it to be anything. You can even consider it to be p and q, and then p plus q will be equal to minus b upon a, and pq will be equal to c upon a. Now remember here children, when we talk about alpha plus beta to be equal to minus b upon a, b is the coefficient of the linear term and a is the coefficient of the quadratic quadratic term. That means b is the number which is multiplied along with its sign, remember, to x, and a is the number which is multiplied again along with its sign with x square, right? So here thus we have alpha plus beta to be equal to minus b upon a, which is minus times the coefficient of the linear term divided by the coefficient of the quadratic term, and alpha beta, that is the product of the roots or the product of the zeros, to be equal to c upon a, which is the constant term divided by the coefficient of the quadratic term. Now children, after we have this, next now we will come over to the sum, and I'd like you people to quickly first give it a try, and if you can't, then look up how we go about with the sum, and obviously after that pause the lecture and then do the sum once all on your own. If you do it twice, I think that's going to be better, and that will register very well with you, so that if it is asked, or probably a sum of its type is asked in an examination, then I'm sure you will do it with ease. Okay children, so now opening up this question, I'd like you people to give it a try. So Takshi trying? Really? Okay. I saw you that you were trying to peep in your partner's copy. That's not good, right? Okay. Now children, here in this question we've been given here that if alpha and beta are the zeros of the quadratic polynomial 5x squared plus 5x plus 1, then find the value of alpha squared plus beta squared and alpha raised to the power minus 1 plus beta raised to the power minus 1. So here children, in this sum what we can do is, first we talk about this quadratic expression that we have, that is we have 5x squared plus 5x plus 1, right? Now children, here we will say comparing this with the general quadratic expression, and then we will get the value of a, b and c. So comparing with ax squared plus bx plus c, we will get the value of a to be equal to 5, the value of b to be again equal to 5, and the value of c to be equal to 1, right? Now children, as we've been given here that the roots of this quadratic polynomial is alpha and beta, so as such alpha plus beta will become equal to minus b upon a, remember, and now in that we are going to substitute the values, that is it is going to become equal to minus b is 5 and a is also 5, as such that gets calculated to minus 1, right? So this children is the first equation in alpha and beta that we have. Now we will move over to the second expression, that is we remember that we have alpha beta to be equal to c upon a. So here now we are going to substitute the value of c and get the value of alpha beta, and that will then become equal to c being 1 and a being 5. So this thus becomes the second equation. Now children, that we have the two equations, now we will use these to solve out the value of alpha and beta, and then we will find out what has been asked to us in the question. Okay, so let's get ahead and let's do this in a form that uses alpha plus beta and alpha beta. So if you talk about the first part here, the first part here requires alpha square plus beta square. Now children, I'll just quickly remind you that there is a formula with the help of which you can very easily do this. That is, if say you talk about a plus b whole square, you know that that is equal to a square plus b square plus 2ab. And as such here, if you talk about a plus b whole square, and from that if you subtract 2ab, then you will get a square plus b square. And thus children, here if you want to write this as alpha and beta, so you can say that if you talk about alpha plus beta whole square, and from which if you subtract 2 times of alpha beta, all replaced in place of a to be alpha and b to be beta, then we will get to alpha square plus beta square as we require. And thus children, here we will now talk about alpha square plus beta square in these terms, and since we know by equation number 1 that alpha plus beta is equal to minus 1, so we will substitute this to be minus 1 and we will square it, and from that then we will subtract 2 times of alpha beta, which is equal to 1 upon 5. Now children, further we are going to solve this out, as minus 1 square will become equal to 1, and this is further going to become equal to minus 2 upon 5. So further here, taking an LCM, which will become equal to 5, you'll have 5 minus 2, which is 3 upon 5, which thus is going to become the value of alpha square plus beta square, right? So this, children, is one of the answers that you have. Now we talk about the second part, right, where we require the value of alpha raised to the power minus 1 plus beta raised to the power minus 1, if I am not mistaken. Yeah. Okay, so next now, children, for that what we do is we now write this as 1 upon alpha plus 1 upon beta. As remember, children, that if we talk about, say, some number a which is raised to the power minus m, then that obviously can be written as 1 upon a raised to the power m. This you've learned in indices, okay, or exponents. Now further here, next what you're going to do is we will now be talking about taking an LCM here. So obviously that's going to become equal to alpha beta, and then here thus you will have beta plus alpha in the numerator. Now you know the value of alpha plus beta is going to be the same as beta plus alpha, as addition is commutative. As such, here we can write this to be alpha plus beta and divide it by alpha beta. Now children, we have the value of alpha plus beta. How much is that? Alpha plus beta is minus 1, right? So that we're going to substitute next here, and then further we'll substitute the value of alpha beta, which, if I remember correctly, is 1 upon 5, right? So next now we can write this as minus 1 divided by 1 upon 5, as this whole denominator sign can be written as the division sign. Now when we convert this division sign to multiplication sign, the fraction which is after it is going to reciprocate. As such, it will become minus 1 into 5 upon 1, or in other words we can write this to be minus 5. And therefore we can say that if we talk about alpha raised to the power minus 1 plus beta raised to the power minus 1, that then is going to become equal to minus 5, and that will become the answer of the second part. Now children, I'll just quickly discuss all of this all over again, so that if you have any problem, right, then all of that is going to be cleared. Yeah, Satakshi, I'm going to discuss it all over again. Anywhere you have a problem, do ask it, right? And at this time you shouldn't be writing, right? So at this time you should drop your pen and just focus where my pointer is, and you should be exactly there, and I can vouch you, I can guarantee you that you'll be able to understand everything. Okay, look up. In this question you've been given that alpha and beta are the zeros, or they are the roots of the quadratic polynomial 5x squared plus 5x plus 1, right? Then you got to find out the value of alpha square plus beta square and alpha raised to the power minus 1 plus beta raised to the power minus 1, right? So further here we first write what the quadratic polynomial is, and then we compare it with ax square plus bx plus c, as is the general quadratic expression. Now we get the value of a to be equal to 5, b to be equal to 5, and c to be equal to 1. Now children, when we substitute here, we will get, by the theory of equations that you studied earlier just now, that alpha plus beta will become equal to minus b upon a, and alpha beta is going to be equal to c upon a. So here children, the value of b is 5 and the value of a is also 5, so that will become equal to minus 5 upon 5, and both of these getting cancelled, it will become equal to minus 1. Now I'm sure you people must be wondering, what is theory of equations? Theory of equations is that theory with the help of which we are able to get these two formulae, that is the value of alpha plus beta and the value of alpha beta, right? Okay, next now, after we get the value of alpha plus beta, which becomes our first equation, now we will get to the second equation, where we'll talk about alpha beta by the theory of equations formula to be equal to c upon a. We have the value of c, right, which is 1, and we have the value of a, which is 5. As such, this becomes equal to 1 upon 5, and that then becomes the second equation. Now you have to solve both of these equations simultaneously to get the value of alpha and beta, right? And then further you got to find out the value of alpha square plus beta square, which is the first expression, and the second expression is alpha raised to the power minus 1 plus beta raised to the power minus 1. So here children, when we have to solve this, what we do is we quickly are reminded of a plus b whole square, which becomes equal to a square plus b square plus 2ab. Now here further, if you bring the 2ab term to the left hand side, you will have a plus b whole square minus 2ab, which will become equal to a square plus b square. Remember, here also we require to find out alpha square plus beta square, so it is somewhat similar, and thus alpha square plus beta square can be written as alpha plus beta whole square in place of A alpha and in place of B beta, minus 2AB will be minus 2 alpha beta. Now we have the value of alpha plus beta as minus 1 that we can very easily substitute here, and then we have to square it like this, and then further from that you go to subtract minus 2 times of alpha beta, and alpha beta also we've calculated to be 1 upon 5 that we can keep here. So here you will have minus 1 square, which will become equal to 1, and minus 2 upon 5. Now as they are fractions, you will take an LCM, so it will become equal to 5, and then further we'll have 5 minus 2, which will become equal to 3. So 3 upon 5 will become the value of alpha square plus beta square. Next now children, we require to find out the value of alpha raised to the power minus 1 plus beta raised to the power minus 1. Now remember, if we have some number which is of the form of a raised to the power minus m, then by the rules of indices, you know that when this number goes over to the denominator, its index will become positive, or in other words, it will become equal to 1 upon a raised to the power m. Similarly here, this can be written as 1 upon alpha, and this can be written as 1 upon beta, and now when you take an LCM, it will become equal to alpha beta, and in the numerator you'll have beta plus alpha. Now as you know that beta plus alpha is the same as alpha plus beta, because addition of numbers is commutative. For that matter, if say we talk about 4 plus 3, we know that that is going to become equal to 3 plus 4, right? That is, the order becomes unimportant when we talk about addition. Thus beta plus alpha can be written as alpha plus beta. We have the value of alpha plus beta as minus 1 that we can substitute, and the value of alpha beta to be equal to 1 upon 5 that we can substitute. Now this whole denominator sign can be written as the division sign, right? As such, we'll have minus 1 divided by 1 upon 5. When we convert this division sign to multiplication sign, we will write the reciprocal of the fraction which comes next. So it will become 5 upon 1. So this will then become equal to minus 5, right? And this, children, is what? It is the value of alpha raised to the power minus 1 plus beta raised to the power minus 1, and thus this is the second answer. So is everybody clear about this? Satakshi, I'm very happy to see that you were focusing perfectly like I told you. That means wherever my pointer is, you are trying to put your focus there, and that is, children, when you'll be able to understand everything. Okay, now this is the reason why I give you a second explanation also, so that if there are some places where bubbles are left, all those bubbles will get burst, right? So is all of this clear? Sure. So I'll take your leave now. Now we'll meet in the next lecture where we study more. Bye.